Hello, Numerate. Welcome back. Okay, so we're in Chapter 3, Section 9, page 248, number 18A. Okay, so we have a baseball diamond. Let's pretend these are straight line segments. Oh, goodness. Wow. I wish we had a decent line drawing thing. Ugh, can I do it? Oh, close enough. Let's pretend that's a baseball diamond, which is a square. Spoke too soon. We're done. Oh my goodness, what is it doing? Why is it doing that? Go away. This editor is really weird. Why is it doing that? Let's see. All right, let's pretend that worked. Okay. All right, so here's this deal. You're running from, let's see, here's home, here's first base, here's second base, here's third base. You're running between home and first base, so say you're here, okay? Question is, how fast, let me think about this. How fast is your distance to first base changing? At the instant that you're running at a rate of 24 feet per second. All right, so let's call this X. No, I know how fast X is changing. What I don't know is how fast you're getting, how fast your distance to second base is changing. Is that what they want? What is the rate of his distance from second base? Right, I'm sorry. Okay, so let's call that Y, that distance, and here's a right angle. And this length S to F is 90 feet. That's a constant. So by Pythagoras, then we have that Y squared equals X squared plus 90 squared. There you go. Okay. So to get the rate of change of Y, let's differentiate everything implicitly with respect to time. You get 2Y, Y prime, I always write it this way, plus equals 2x, X prime, and so to get dy dt, we need to know Y. Well, let's see, we can figure out Y. Plug in X is, oh, he's halfway. At this moment, X is 45. He's halfway between home and first base. Okay, so we know X is 45, so Y is the square root of 45 squared plus 90 squared at that instant. Right, just plugging in 45 here. Alrighty, so we got Y. We got to get dy dt. We got X. It's at this moment 45 feet, and we got X prime. At this moment, it's 24 feet per second going toward F, meaning that X is decreasing, so negative 24 feet per second. And the twos cancel, right? So if we divide both sides by Y, we end up with dy dt, or Y prime, is X, which is 45, times the X dt, which is negative 24 feet per second, divided by let's see, rad 45 squared plus 90 squared. Yeah, boy. All right, so let's simplify that a little bit. Oh, what is this? Oh, ignore that. All right, so I'm going to put this into my calculator. Let's see, so 45 times negative 24 is 1,080, negative 1,080. So we got that dy dt is negative 1,080 over, all right, so 45 squared is 2025, and 90 squared is 8,100. So we get 8,100 plus 2025 is 10,125. 10,125 square rooted. Oh boy, that looks to me like you can take out at least 25. Well, I guess you could reduce that, but let's see what that is. So negative 1,080 divided by the square root of 10,125 is approximately negative 10.733 feet per second. So I'm going to say that's approximately negative 10.733 feet per second. That's how fast y is changing when you're running first base, halfway there. Okay. Now that's 18A. 18B says, what's the rate of this distance from third base? At what rate is it increasing? Okay. So if we look at this diagram, what if we make this y, I'll call it z. What if we make this z here? The rate of change of the distance between t and the runner, I guess that's r, tr, let's call that z. Again, we have a right triangle here. At the same instance that, let's say this x, let's call this x, is also 45. But now dxdt is positive because this length hr is increasing. So, and this is 90 again. That's a constant. So don't we have the same exact thing, but it's increasing? So y is decreasing and z is decreasing at the same rate. Y is about negative 10 feet per second and z is about positive 10 feet per second. Just by symmetry, right? Because it's the same equation. Pretty much, I'm just calling it z instead of y, and x prime is positive. So 18b by symmetry is about, it gives you dz dt is about positive 10.733 feet per second. All right, thanks, Numeri. That was fun. Have a good day. Good luck with your studies. See you next time.